Okay, for today's experiment, this is what you're going to need to get. Some food colouring, it could be any colour. A glass that you can put hot water in, and a drink bottle. Okay, so if you don't have those things, you can press pause and go and grab them. You also need a kettle to boil some hot water. Okay, once you've got all your things, first thing we're going to do is put the water on and boil some hot water. Next thing we're going to do, I want you to fill your glass about 3/4 with cold water from the tap. That'll do. Okay, grab your food dye and your drink bottle. We're only going to need a little bit of hot water in this drink bottle, maybe about up to there. So see my finger? So put a little bit of food dye. Be generous enough though, because we want it to be a strong colour. Then you're going to put hot water from the kettle. You only need a little bit. So that's enough, and it's nice and red, which is good because I want to be able to see the coloured water. Okay, next what you're going to do, actually I need a little bit more than that. I'm going to put a little bit more of tap water. So it's a bit more than 3/4 actually. Now what I'm going to do is really slowly pour my hot water down the side of the glass. That's why I've got a drink bottle, because it's got a nozzle. And we're going to watch what happens to the coloured water. Oh, that was a little bit too fast. So if I put my finger on it and put it up against the side wall of the glass, you could do it a bit better. And that should be enough. Now let's get a close-up of that. If you've ever had traffic light drinks before, they look a little bit like that. So we've got the red water, and you can see that it's floating on top of the clear water. So the red water is hot, and the clear water is from the tap. We're going to do another experiment and see what happens if the red water is not hot. So we'll leave that one there. Because I know what you're thinking. You're probably thinking maybe it's the food dye that's making it float. Aha! If that's really what we're thinking, we need to do another experiment and make sure that that is not what's going on. Is it the food dye making it float? We don't know, so let's try it again. This time, do exactly the same thing, but instead of getting hot water, we're going to get cold water from the tap for our bottle. So now I've got cold water from the tap, and I'm going to do exactly the same thing, and we can compare them. Bottle's still a bit warm. So hold it nice and gently and let it trickle down. And let's have a look at that. So we can already see that that hypothesis is not correct, because our cold coloured water mixes really well, but our hot coloured water doesn't mix. So why does hot water float on top of cold water? Well, we can only explain that by using particles. So remember, solids are made up of particles which are strongly held together. So particles are close together. In liquids, the particles are further apart, and in gases, well, they're really, really far apart. Remember that particles are always moving, even in solids. So even in this felt tip and the table, the bench that I'm writing on, they're solids, and the particles are always vibrating, kind of like this. But they're just vibrating in small amounts. In solids. In liquids, particles are moving quite a bit more, and they can slide past each other, which explains why liquids are fluid. In gases, particles are free to move because they're not strongly held together by bonds. So particles are going crazy just in all sorts of directions, and they'll hit the container that they're in. They'll fill up any container, they'll take up a lot of space, or they'll just hit the wall when they come to it. So what holds the particles together? Well, it's bonds. I'll write that down. So bonds in between the particles hold particles together. A fancier word would be intermolecular forces, but we can just use the word bonds. So the bonds are really, really strong in solids, and that's what keeps the particles close together. In liquids, the bonds are less strong, so they can slide against each other and move around a little bit. In gases, there's hardly any bonds holding the particles together, and the gas particles are free to just move very fast in all sorts of directions. When we give heat or energy to particles, it makes the particles vibrate even more. So because they start vibrating even more, they can break the bonds or the intermolecular forces that are holding them together, and that can cause the substance to turn into a liquid. If we give heat to the liquid, these particles start to vibrate even more, and the forces that were keeping the particles together in the liquid, the intermolecular forces or the bonds, they get broken, and then we can have this substance turning into a gas. There's hardly any bonds or intermolecular forces holding the gas particles together, and that's why gas particles are moving so quickly. They actually move in straight lines, but they move really, really fast and in all sorts of straight line directions, so they'll just fill up any container or escape from the room if they're not contained. So what's all this got to do with our hot water that was floating? Okay, so we had our glass of water. Here's the cold water, and on top we poured the hot water. And what we saw was that the hot water floated on top. I'm going to draw what the particles might look like in the hot water. So here are the particles for the hot water. You can see that there's a few gaps in between them. Here are my particles for the cold water. There are fewer gaps between them, and the bonds are holding the liquid slightly stronger together. Why? Because remember, we heated up this water, so it made the particles vibrate even more in the hot water, and some of the bonds started to get breaking. This means there's less particles in the hot water than there is in the cold water for the same amount of volume. The word for this is density. So density means the amount of particles in a given amount of volume. So the amount of particles is less in the hot water, so we say that is less dense. And the amount of particles in the cold water, there's more of them, so we say it's more dense. So because the hot water is less dense, it floats on top of the cold water. I've written down 5 statements that explain why the hot water floats, but they're not in the correct order. Your job today is to read these statements and put them in the correct order.